Section 2.8 is on graphing linear and absolute value inequalities, and we'll go over some examples of both. Okay, so first, if you're going to be graphing linear inequalities, first put the line into slope-intercept form, and slope-intercept form is in y equals mx plus b, or you can graph it by using the x and y intercepts if it's in standard form. If it's not already in standard form, I would probably go ahead and just use slope-intercept form. I know you have graphed inequalities before, and the things you need to remember is if you're graphing an inequality that has a less than or a greater than, you're going to use a dotted line because we're not including the solutions that are on the line. And if you have a less than or equal to or a greater than or equal to symbol, you will use a solid line because we are including the solutions that are on that line. We also have to shade the graph because you're not just using the solutions that are on the line, it's all the solutions on the line and to one side or the other side. So we're going to test a point. We're going to test a point that's not on the line. We're going to plug it into the inequality. If it makes the inequality true, we'll shade on the side that the point is on. If it makes the inequality false, we'll shade on the opposite side that the point is on. Okay, our first example is y greater than negative 3x minus 2. This equation, or inequality, is already in y equals mx plus b form. So I'm going to go ahead and graph this using slope-intercept form. So I'm going to go to the y-intercept of negative 2. And then I'm going to see that the slope is negative 3 over 1. So from my y-intercept, I'm going to go down 3 and right 1 and put a point there. And then I'm going to go down 3, right 1. And if I want to draw a more accurate line, which I always do because my lines aren't very good, I'm also going to go back to my y-intercept and I'll go up 3, left 1. Okay, and now, before I draw on my line, I have to think to myself, do I want a solid line or a dotted line? And because I do not have an equal to bar underneath my inequality, I just have a greater than symbol, that means I want a dotted line. So I'm going to go ahead and draw my dotted line. Okay. And now I need to decide where to shade. So I'm going to pick a point that's not on my line. So it's often easiest to pick 0, 0, but since my line isn't the most beautiful line in the world and I can't tell exactly where 0, 0 is at, I'll pick another very easy point. I'm going to test 1, 1. So I'm going to plug 1 into my inequality, and I'm going to see if I end up with an inequality that's true or false. So negative 3 times 1 is negative 3 minus 2, so I get negative 5. So the question is 1 greater than negative 5? And 1 is bigger than negative 5, so that's true. So I'm going to shade on the side that the point is on. And so now I have graphed my linear inequality. If I were to choose any point in the shaded region and plug it into my inequality, it would make the inequality true. All right, here is an inequality that is not in slope-intercept form. It is in standard form. We can use it in standard form. Let's go ahead and graph this in standard form since we already have it. So what I'm going to do is use the intercept method. So if I want to find the x-intercepts, I'm going to plug 0 in for y, so I would cover up my y term and I would divide both sides by 3. So I would get 2/3 for my x-intercept. So 2/3. I'll do the best. Oop, that's too big of a dot. So we'll go to a smaller dot. And I'll see if I can get it on 2/3. It's close to 2/3. Okay. And then if I want to find the y-intercept, I would cover up my x term and I would divide both sides by 1/2. Now be careful here. 2 divided by 1/2 is 2 times 2 over 1. So that is 4. So then my y-intercept is at 4. So I have my 2 intercepts. Again, I have an inequality without an equal to bar on it, so that means I have a dotted line. So I'm going to draw in my dotted line the best that I can. And then I need to test a point. Now this time I am absolutely certain that 0, 0 is not on my line. So I'm going to go ahead and test 0, 0. So I'm going to plug 0 in to my inequality and see if my inequality is true or false. So the question is 0 less than 2? And 0 is smaller than 2, so I can go ahead and shade on the side of my test point. If that had been a false inequality, then I would have shaded on the other side. So if I picked any point in the shaded region and plugged it into my inequality, then that would make my inequality true. Alright, so here's one more. You should try this one on your own. So you've got negative x plus 2y is greater than 4. It is in standard form, so you can go ahead and pause this and then try to see if you can graph this and see if you get the same answer that I do, and then you can play the rest of it to see if we get the same answer. So I'm going to find my intercepts again because it's already in standard form, so I'm going to leave it the way it is. I'm going to use my cover-up method. I'm going to cover up the y term. I'm going to divide both sides by -1, so that's going to give me a -4. So I'm going to put an x-intercept at -4, if my stylus will cooperate. Okay, there you go. And then I'm going to cover up the x term, and I'm going to divide both sides by 2, and that will give me my y-intercept. And so that will give me a y-intercept of 2. Again, I do not have an equal to bar on my inequality symbol, so I have once again a dotted line. It won't always be that way, but it has been for the last 3 examples. And then I need to test a point. So I, again, like to test 0, 0 if it's not on my line. So I'm going to test 0, 0. I'm going to plug that into my inequality. And I'm going to see if I end up with a true or a false inequality. So my question to myself is 0 bigger than 4? And that is false. And because that's false, that means I'm going to shade on the opposite side that my dot is on. So my dot was on the side with 0, 0. I have to shade on the other side. And again, this means that if I pick any point on the shaded side and plug that ordered pair into my inequality, it will make my inequality true. I hope your line looks a lot better looking. Okay, so here is an application problem. So it says, a recreation center offers various 30-minute and 60-minute art classes. The recreation director has allotted up to 20 hours per week for art classes. Write an inequality to represent the number of classes that can be offered per week. Graph the inequality. So we see that there are 2 different kinds of classes. One is a 30-minute class and one is a 60-minute class, and it tells me how many hours I have total for classes. Okay, so if I let x equal we'll call it 30-minute classes, and y equal a 60-minute class. That's number of 60-minute classes. So number of, not the hour, the number of minutes of. Then I can set up an equation or an inequality that states that if I have 30 minutes times however many 30-minute classes plus 60 minutes plus however many 60-minute classes, that should equal the total number of minutes per week. Now, it does say that I only have up to 20 hours per week, so I think I'm going to have to take that away and say I have to be less than or equal to 20 hours per week. Now, 20 hours is in hours, and these other two numbers are in terms of minutes. So I have to make a choice. I either need to put my minutes in terms of hours, or I need to put my hours in terms of minutes. I actually think that I will go ahead and change these to be in terms of hours. So I'll say a half of an hour times the number of 30-minute classes plus 1 hour times the number of 60-minute art classes has to be less than or equal to 20. And I think this will be easier to graph, so that's why I picked doing it this way. I know that I can't be more than 20 minutes, but it looks like I could, 20 hours, but I can be up to 20 hours, so my less than or equal to symbol should work just fine. I also see that I have a graph here, and I don't get to pick how many tick marks I have, so I'm probably going to have to go by 2's here. So I'm going to indicate that I'm going to go by 2's on the y-axis. I think I'm only going to go by 1's on the x-axis. Yeah, I think I will. Okay, so then I'm going to, since this is in standard form, I'm going to use the intercept method. So if I go ahead, oh, you know what? I just noticed that if my x-intercept, if I cover up the y's and I divide both sides by a half, I'm actually going to end up with 40 for my x-intercept. So I think I'm actually going to have to go by 4's on my x-axis. So I'm going to change my mind there. So 4. So here, oh, way over here is 40. Okay, so I have an x-intercept at 40. And then I have a y-intercept. If I use the cover-up method again, cover up my x terms, and I divide both sides by 1, I'll get 20 for my y-intercept. So there's my y-intercept. And this time my inequality symbol does have an equal to bar underneath it, so I'm actually going to have a solid line this time. And I'm going to try to hit those points. Sorry about that. And so that means that all of my solutions, I do have solutions actually on the line as well as on the shaded part. So now I need to decide where to shade. And if I'm shading, I would also, again, like to pick 0, 0. And I'm going to test the point 0. So 1/2 times 0 plus 1 times 0 less than or equal to 20. So I ask myself, is 0 less than or equal to 20? And that's true. And so that means I'm going to shade on the side with 0. Now, I need to be kind of careful because this is a real-life situation, and I have to realize that if x is negative or if y is negative, then that means that I have negative amounts of art classes, and I don't think we can have negative amounts of art classes. So I'm going to go ahead and erase the parts that are shaded and the negative parts. So then I just have this nice little triangle in the shaded in part. And so if I picked any point either on the line, and of course the line as well should be cut off at the axes because that would indicate that I have negative amounts of art classes. So if I pick any point that is on the blue line or in the red shaded part, that would make my inequality true. So that is an example word problem that has an inequality. Okay, so then on a follow-up question, let me put my equation back in here. I believe it was 1/2 x plus 1y is less than or equal to 20. So that was my inequality. Part B here refers to this inequality. It says, can the recreation director schedule 25 of the 30-minute classes and 15 of the 60-minute classes during a given week? Explain your reasoning. Well, if they can schedule these amounts of classes, then I should be able to plug them into my inequality, and my inequality should be true. So let's try it. So I want to have 25 of the 30-minute classes, and I want to have 15 of the 60-minute classes, and I'm going to see if that sum is less than or equal to 20. Well, half of 25 is 12.5, and 1 times 15 is just 15. The bad news is, though, that this is 27.5. And that is not less than or equal to 20. So no, the classes will take too many hours. Okay, and so that will be our solution one. All right, so that will take us to the end of linear inequalities, and now we'll work on absolute value inequalities. And hopefully you remember some of our transformations that we have done before. And we also have to think about what our parent graph looked like. So I believe the day before that you've had parent graphs for absolute value of x. So you might want to think to yourself, just real quick, that absolute value of x is that V-shaped thing. So this is what goes on in my head. It's a big mess, just like this graph. That I always think I'm starting with absolute value of x. So this is the parent graph I'm starting with. Then I have to think about what transformations are taking place. So when I see the +3, that is a shift up 3. And when I see the 2 on the outside, so if the 2 is being multiplied times my parent graph, that's a vertical stretch. Okay, and it is by a factor factor of 2. So it's a vertical stretch by a factor of 2. What that means to you is I'm going to make you make a t-table for this, because that means I actually need to plug in numbers and multiply through and find some points. Because if I'm just shifting, I could take my parent graph of absolute value of x and just shift it up 3. But since I have a vertical stretch, that's going to change things a little bit. The good news is with an absolute value graph, that 2 actually is telling you the slopes of the lines. So that changes that positive slope of 1 to a slope of 2. And it changes the left side, which is a slope of -1, to a slope of -2. But I'm still going to make a t-table just to convince you. And so I'm going to get rid of this so I have room for my t-table. And it's always good to pick some negative points and pick some positive points. And I'll pick -2. Since it's not shifted left and right, I'll choose -2, -1, 0, 1, and 2. I think we can do this quickly enough. If I plug in -2, absolute value of -2 is 2. 2 times 2 is 4. 4 plus 3 is 7. If I plug in -1, absolute value of -1 is 1. 1 times 2 is 2. 2 plus 3 is 5. If I plug in 0, absolute value of 0 is 0. 0 times 2 is still 0. Plus 3 is 3. If I plug in +1, absolute value of 1 is 1. 2 times 1 is 2. 2 plus 3 is 5. And then if I plug in 2 for x, absolute value of 2 is 2. 2 times 2 is 4. 4 plus 3 is 7. So I'm going to plot these points on my graph. So there's negative 2, 7, negative 1, 5, 0, 3. So I can see my vertical shift of 3 there. 1, 5, and 2, 7. Now I see my V shape. I definitely should have a V shape because it's an absolute value. So if you only see one side of your V, that's not good enough. If you have an absolute value, there should be a V somewhere on your graph. I also see that I have an equal to bar underneath my inequality symbol. So that means I'm going to do solid lines. Ooh, kind of missed there. Sorry about that. And so now I need to decide where to shade because it is an inequality. So that means I do need to shade my graph. So again, I can test a point just like I did before. And I'm going to plug that into my inequality. So 0 less than or equal to 2 times absolute value of 0 plus 3. Anything times 0 is still 0. So the question is 0 less than or equal to 3? And 0 is less than or equal to 3. So I'm going to shade everything on this side with the point. Now when I talk about a side, it's either going to be inside the V or outside the V, or in our case, since we have a V, it's either going to be above or below. So if it's a less than, it's going to be below the V, and if it's a greater than, it's actually going to be above the V, or inside the V shape. So if I picked any point, either on the V or in the shaded blue part, it should make that inequality true. Try this one. This one looks a little bit more complicated. It says y plus 8 is less than 4/3 times the absolute value of x plus 9. So again, it has an absolute value. So I'm thinking to myself over in the corner of my brain that I'm starting with an absolute value graph. Oops. There's my messy absolute value graph. Okay. Now, I want to get y by itself. So I'm going to get y by itself. And so that's y less than 4/3 times the absolute value of x plus 9 and then minus 8. Okay, so a few things going on here. I have a vertical stretch of 4/3. So that is going to mean on an absolute value graph that my slope is 4/3 and negative 4/3. And then my x plus 9 in absolute value bars, that's going to be a left shift of 9. So anything in parentheses or in absolute value bars, if it says plus, it's going to go left. If it says minus, it's going to go right. And then the minus 8 outside of the absolute value bars. So if you have a minus or plus outside of parentheses or outside of absolute value bars, that is a shift down 8. Okay, so I know that my vertex of my V shape, that should be at negative 9, negative 8. And then I should have my slope should be 4/3. Okay, but I did promise you that if I had a vertical stretch, I was going to plug in points, which I'm going to do. Now, since I have a shift left of 9, I'm not going to start my t-table at 0, 0. I am going to shift it over also 9 points. So if I wanted to plug in negative 1, instead I'd shift it left 9, so I'd plug in negative 10. And if I wanted to plug in 0, I'd shift that left 9, so I'd plug in 0. Or not 9, sorry, not 0, I would plug in negative 9. And if I wanted to plug in positive 1, I'd shift that left over 9 units to the left. So that's really negative 8. So let's see what this gives us. Negative 10 plus 9 is negative 1. Absolute value of negative 1 is 1. 1 times 4/3 is 4/3. 4/3 minus 8. So what I need to think of is I am taking 1 1/3 minus 8, or you know what, we could just do the fractions since we all love fractions so much. Oops, sorry, I got a little excited about getting a common denominator. 4/3 minus 8 over 1. So I need to get a common denominator. And I'm doing a little bit more work than I have to, but I want you to have a strategy just in case that you don't have an easy equation to do. So this would be 4/3 minus 24/3. So that would be negative 20/3. Okay, so this is negative 20/3. All right. Then I'm going to plug in negative 9 into my inequality. And if I plug in negative 9, I'll get 0. 0 times 4/3 is 0. And then I get negative 8, just where I thought my vertex would be. And if I plug in negative 8 plus 9 is 1. 1 times 4/3 is 4/3. And we just found out that 4/3 minus 8 is negative 20/3. Okay, so now we're going to graph this. So I'm going to go to negative 10, negative 20/3. So I have to remember that negative 20/3 is negative 6 2/3. So I'm going to put it about there. And then negative 9, negative 8 is right here. And then negative 8, negative 20/3 will be about there as well. Okay, now the good news is that I don't have a lot of space over to the left. Oops, and oh, I have to be careful because I have to think about, do I have a less than or equal to, and that's a less than, so it does not have a solid line. And then the other side I can just kind of extend up. Now if I want to be careful, which I probably should, I should try to go up 4 and right 3. Yep, and I'm right about on it. 1, 2, 3, 4, 1, 2, 3. Then I got a little off track there. So it should be about there. Okay, so there's my absolute value inequality. And now I need to shade, and since y is by itself over there on the left, I can look at that thing and I can say, oh, that's a less than symbol. I can shade below. But if I want to double check, go ahead and plug 0 in for x and 0 in for y. And if you went ahead and did that, it should be true. That would give me 9, that would be 12 minus 8. So I get 0 is less than 4, which is true. And so that I would indeed shade on the side with 0, 0. So this is going to be everything below my V shape. Example, you're going to try to graph y greater than or equal to 3 times the absolute value of x plus 1, and then you're going to pause, and then you can check to see if you got it correct. This 3 is a vertical stretch. One moment. Okay, vertical stretch of 3, so by a factor of 3, so that's going to give us a slope of 3 and negative 3 on either side. This plus 1 is in absolute value bars, so that's like parentheses, so that is a left shift 1. Okay, so that is our left shift of 1. So I am going to make one more table. Now since I have a shift left or right, again I'm going to shift my ordered pairs, so I'm not just going to start at -1, 0, and 1. I'm going to shift them all to the left, so I'm going to choose -2, -1, and 0. So if I plug in -2, -2 plus 1 is -1. Absolute value of -1 is 1 times 3 is 3. If I plug in -1, -1 plus 1 is 0. 3 times 0 is 0. And then if I plug in 0, 0 plus 1 is 1. Absolute value of 1 is 1. 1 times 3 is 3. So then I can plot my points. I can go to -2, 3, 0, or -1, 0, and then 0, 3. I see that my inequality symbol has an equal to bar, so I need to have solid lines. And I also see that if I, from my vertex at -1, 0, if I would go up 3 and right 1, up 3, right 1, I would be pretty much on target. And then I need to decide where to shade it. It is a greater than symbol, so I should be grading or shading above or inside that V shape. And that would keep going forever up here. And that means if I picked any point on the red line or in the blue shaded part, I would make that inequality true. And I could have also tested a point at 0, 0. We could have tested 0 greater than or equal to 3 times the absolute value of 0 plus 1. And I would find out that 0 is not greater than or equal to 3. And so that means it's not true at 0, 0. So that means I do not want to shade on the side of 0, 0. So that means I want to shade on the other side, so that would be inside the V. Okay, so that is all the examples that I have for graphing linear inequalities and absolute value inequalities. If you have any questions, let me know.